Hello there, you amazing people. In this video, we will be creating our first neural network. And the simple neural network that we are going to create is going to mimic this particular function. So we will be creating two simple neural networks that will mimic this function. The first neural network, which is actually not a neural network, but a single neuron, is going to mimic this function. And the second one that we are going to create is going to be a two-layered simple neural network that is going to simply look like this. Here I will be giving my input, there will be some weights and a bias will be added, and after that I will be receiving some output. And in this case I will be giving my same x, there will be some weight here, there will be some weight here, and there will be some bias here, there will be some different bias here, and after that I will be receiving output from here after the forward propagation step. So this is all we are going to create in this particular video. To begin with, you have to first start with importing your necessary libraries and modules. So you have to import your TensorFlow and your Keras and NumPy. It is okay if you don't import this one. You will see why I'm saying that later on. After this, you have to create your simple input. So the input that I'm going to create contains the values, a list of values ranging from -1 until 5, and these are going to be my x values, and corresponding to my x values I have my different y values. Whenever my x is -1, my y value is going to be -3. Whenever x value is going to be 0, my y value is going to be -1, and so on until whenever x value is going to be 5, my y value is going to be 9, and these are my y values. So these are my x values here, and these are my y values. These represents my inputs and these represents my output. Now we have to instantiate our model. In order to do that, you have to first define what type of model you want to make, and after that you have to pass on the different layers that you want your neural network to have. So in the first simple neural network that we are going to create only contains one layer, and that too only with one neuron. So our first simple neural network is going to look like this. Now you can see that there is only one layer, so number of layers is equal to 1, and number of hidden neurons or neurons is going to be equal to 1. And also you know that by default most of the neural networks have sequential nature in structure. So what does sequential mean? So you see that in many of the neural networks, or not, I should not say many, in almost all the neural network that you will encounter later, you know that they follow a architecture like you have to pass input from one side and you will receive your output from the other side, where all the layers are sequentially connected in front of each other. That is, all the layers are stacked in front of each other, and I have to pass input from one side and I will be receiving my output from each side, from the other side. So this type of model is known as sequential because all the layers are stacked in front of each other sequentially, therefore sequential. Also, you must be knowing that the layers are densely connected. That is, each of my layers is densely connected to each other. So because they are densely connected to each other, hence I have made sure that my layer type is dense in nature. Also, the forward propagation step is done by using the dense layer. Inside the dense, you have to pass the number of neurons you want that particular layer to have. And whenever you are creating your first layer, whenever you are going to create your first layer, you have to pass your input shape. So my simple neural network, my first simple neural network is going to look like this. Here there is only one layer, and also there is only one neuron. Therefore, I have passed here input shape as 1. Therefore, I have passed my input shape because this is my first layer, and also since it contains only one neuron, therefore units is equal to 1. Now, why is input shape 1? It is because I have used a 1D array to as my input. You can see my input looks like this. You can see that it is like a one-dimensional array. Therefore, I have passed my input shape as 1. Now, there is another method to instantiate my model, and the benefit of using this method is that it will help you to inspect the weights and the bias later on in the later stages. Suppose you want to inspect what is the weight of my particular neural network. Here in this case, there is a simple neural network, that is, it contains only one neuron, therefore it is not necessary to know the weights. But suppose in later stages you create some complex model. Suppose your model looks something like this. Now if you want to inspect particular weights, suppose if you want to inspect the weights present in this layer, or you want to inspect the bias present in this layer, then if you want to perform manual inspection, you can do that with the help of this instantiation method. So what in this method, what you have to do is you have to predefine your layers. So I have first defined my layers. Since my layers are densely connected, therefore I have used my layer type as dense. Since I am using only one neuron, therefore units is equal to 1. Since I am passing a 1D array, therefore input shape is equal to 1. Everything that I have earlier repeated is going to be repeated here itself. Now since my model type is going to be sequential, because all my layers are going to be sequentially connected, even though I'm just using one layer, but still it is sequential in nature, because I have to pass input from one side and I will be receiving my output from the other side. Therefore I am going to use sequential type, and I have to pass my layers inside here. So this is my other method to perform instantiation. You see that in professionally, in most of the cases, when you will be seeing your code, or whenever you will writing your code, you will be mostly using this type of formatting. You will be writing in this way, that is, you will be creating a sequential, and inside that you have to pass the different layers that you want your model to have. But if you want to perform manual inspection, but in case you want to see if you want to see the inner workings of your model, the inner weights, the inner biases, then you have to use this method. Otherwise you have to just use this one. Now you have to train your model, and in order to train it, you have to first compile your model, and then you have to fit your model. So inside the compilation stage, you have to pass what optimizer you want to use, and what is the loss function that you want to use. And if I will be covering optimizers in the later videos, but for now on, if you want to gain an intuition that what is the work of an optimizer, so you must know that if I am creating suppose I am given a task. Suppose someone has given me a task that you have to create a model in such a way that if I pass my suppose I pass -1 as input, I will be getting suppose -3 as output. If I will be passing 0 as input, I will be getting -1 as output. If I will be passing 1 as input, I will be getting 1 as output. So suppose I want to create a relation, I want to create a function that looks like this, that does this particular function, that has this particular functionality. So what I can do is, if I have to do this manually, I will be employing the method of hit and trial. That is, I will be trying different values, I will be writing random functions, and based upon the observations that I will be getting from one, I will be making improvements. For example, if I see this problem, what I can think of is, let us suppose square my x value. So if I square -1, I will be getting 1, which is not equal to my y. Therefore, this method is wrong. Suppose in my second method, what I can do is I can multiply this x value by 3. So -1 multiplied by 3 will give me -3, which is equal to my y1. But if I do this for the second value of x, that is 0 multiplied by 3, I will be getting 0, which is not equal to my y2, that is this. Therefore, this function is also wrong. And after several hit and trials, what I can do is I can find my required function, which is 2x minus 1. Now if I pass my input, I will be getting my respective output. If I pass -1, I will be getting -3. If I pass here 0, I will be getting -1. So I will be getting these values. So by various hit and trial methods, I am able to find my correct function. So my work of my optimizer is to do this guesswork. My loss function will calculate my loss, that is how far my predicted value is from my actual value. And based upon that loss function, the work of my optimizer is to guess the next value of my function. So this guesswork, here my human brain does the hit and trial. In case of deep learning, optimizer does the guesswork. So this is how you can relate the concepts. The concept of optimizer is a little more deep. You have to learn it. But for right now, in order to gain an intuition, you must be simply knowing that the work of optimizer is to perform the guesswork. and is to improve my parameters, my weight and bias depending upon my loss values. Now I have to fit my model, and the number of epochs I'm going to be using is 600, and X is my inputs and Y is my output. And after that, my model will be trained. Once training has been completed, once training will be completed, you will be ready to perform your predictions. Now you can simply write model.predict and pass your input. For example, you must be knowing that my function is 2x minus 1. Now if I write here 10 in place of x, what I can do, what I will get is 2 multiplied by 10 minus 1, which is going to be equal to 19. Now you can see that if I'm using model.predict, I'm getting output as 18.991243, which is approximately equal to 19. Similarly, for 11, I'm getting 20. I'm getting approximately 21, and for 12, I'm getting approximately 23. So you can see that my machine learning model is working exactly as I'm expected. Not exactly, but almost exactly like I want to expect. You can see that there are decimal values coming. I'm getting 18.99 something something, but not 19. Why is that? It is because my deep learning model works on probabilities and not certainties. So this is a point you need to keep in your mind. My deep learning model, my machine learning model works on the basis of probabilities and not certainty. And also another reason why it is not giving certainties is because I have used very few number of inputs. I've just passed minus 1, 0, 1, 2, 3, 4, 5. The data set that I have given to my model is very small. That is also my prediction is not exact. So these are the reason behind getting these decimal values. Now let us see how can we inspect my neuron. You must be remembering the method that we earlier employed, that is instantiation method 2, where I first define my layers and then pass my layers inside my sequential model. So now if you want to inspect your weights, you can do this by simply calling the function getWeights. So suppose this is my simple neural network. This is my input. There is some respective weights and the respective y's, and I will be getting some output. So if I use dot get weights function, I will get this weights and this bias. You know that my function looks like this. Here, this is my weight and this is my bias. Sorry, this is my bias. And okay. So you can see that 1.9985 is approximately equal to 2, which represents my weight. And you can see that here minus 0.99 is approximately equal to minus 1, which represents my bias. So you can see that in this way you can gain the different bias and the different winds present in each layer and the neurons present in that layer. Now I'm going to create a neural network that looks like this. Here you can see that there are two layers. In the first layer there are two neurons, and in the second layer there is only one neuron. And in the first neuron I'm giving only one input, that is one input. And now I'm going to create and train my model. So I'm going to first create my layer number 1. Remember, in first layer you have to pass your input shape. So since this is my first layer, therefore I'm passing my input shape as 1. Since in the first layer you can see there are two neurons, therefore I have passed here units is equal to 2. Also, because my layers are of dense type, densely connected, therefore I have used dense here. In the second layer there is only one neuron, therefore I have passed here units is equal to 1. And because it is second layer, therefore it is not necessary to not necessary. You don't have to pass your input shape. Now I have passed it inside my sequential model, and then I am training my model by using my compile and fitting. Here in the earlier approach, you must be remembering that I had used about 600 epochs, but since now I'm using more than one neuron and more than one layer, therefore my model accuracy is going to increase. And now I'm going to use I'm going to reducing my number of epochs, because by lesser epochs also I'm going to get more accuracy than the earlier approach, simply because I have more layers and more neurons. Once you will be training your model, you will see that you will be able to predict. Yeah, you will be able to make predictions be using your model. So when I pass 10, I'm getting this as output, which is approximately equal to 19. And you can see that my model is working just like the way my earlier approach was working. Now, if you want to perform your inspection, you can just use your get weights method on the different layers. If I use my get weights on layer number 1, you will be getting the respective weights and the respective biases. And if you will be using your get weights method on your layer number 2, you will be getting your respective weights and biases. If you want to get the particular weights, for example, I want to get the weights of that neuron, that is present in the first layer, and also it is the first neuron. So in order to do that, I'm just simply going to write here my layers, use the get weights function, and after that, since I am going to be using weights, therefore I have passed here 0, because my first array represents weights and the second array represents my biases. And after that, since I'm just using my first neuron of that first layer, therefore I have to pass here 0, and then I have to pass here 0 because I want to get my initial value. In this way, you will be getting the weights of that particular neuron that's present in the first layer, and also it is a first neuron of that particular first layer. So I will be getting that weight. And if you want to manually perform your coding, manually do your neural network manually, so what you can do is you can get your respective weights, you can get your respective biases, and then you can simply calculate your output by doing the matrix multiplication, and you can simply get your output. And you can see that here also my output is coming equal to the output that my model done without manual inspection. So this is how you can create your simple neural networks. In this particular video, we learned that how can we create simple neural networks. We first created a network that contained only one layer as well as only one neuron. And in the second one, we created a simple neural network that had two layers. The first layer contained about two neurons and the second layer contained one neuron. So that was all for today, guys. I hope you understood the video perfectly. If you were stuck in some point, then I recommend you to repeat that part again and try to use your logic that why is that happening. And we will meet in our next video. Until then, bye bye.